let's quickly revise what are trigonometric ratios and why we actually need them and what's special about these ratios. So far we have some tools that help us to work with triangles. So let's say if we have any triangle, if absolutely any triangle, right, obtuse, acute. So if you have two angles, let's say this is 60, this is 40 degrees. So if we have two angles, we can always find the third one by using the rule that all angle measures should add up to 180. So to find this angle, let's say we're going to take 180 minus sum of the other two, and that will give us 80 degrees. So your missing angle is 80 degrees. So this is the first tool we have for any triangle, any, right? Tool number two, we have something for right triangles. Can you remember? If we have a right triangle, it must be a right triangle, and we have two sides, we can always find the third side. So we have a Pythagorean theorem, right? Theorem. And let's say if we have 3 and 4, we can always find the missing side. It can be a hypotenuse, can be one of the legs. And the rule is hypotenuse squared equals to leg squared plus another leg squared. So if you find square of hypotenuse, you can always take a square root and find the third side. So again, we have 180 rule and we have Pythagorean theorem. For this, again, we need two legs or two sides, any two sides, to find the third side. Now, trigonometric ratios give us some special settings to solve. So for trigonometric ratios, all what we need, just one side and one angle. And we already know that this is a right triangle. So trigonometric ratios will work for right triangles only. We will have some rules for non-right triangles, but not now. So if you have a right triangle and you're given a side, so let's say this side is 5, and this angle is 30 degrees. So this is enough to find any of the two remaining sides. Okay, and we're going to talk about how to apply trigonometric ratios to find missing sides in the next video, or even find missing angles. So trigonometric ratios help us to find missing sides and missing angles. If we have two sides given, we can find missing angle, or one side and one angle is enough to find the remaining of a triangle. So again, Pythagorean theorem will not work here. Actually, we can use special right triangle here, right? We have 30 degrees, but I can take any angle. So I'll change it so we cannot use special right triangles. So this is enough to find the other two sides. So let's define these trigonometric ratios. So usually we use like a right triangle with, let's say, sides A, B, C. So let's call it A, B, C. We call, we use capital letters for angles, and we're going to use lowercase letters for sides. So side opposite to angle A, we're going to call it a lowercase a. Side opposite to angle B is lowercase b, and side opposite to angle C will be lowercase c. So what is sine, cosine, and tangent? And I will write it here. It's very silly, so katoa. It's very silly, but somehow it's so silly, so it sticks in your mind. Now, what is so stands for? This stands for sine, definition of sine. So sine of an angle is the ratio, it's just the ratio, it's two numbers divided by each other. So sine of an angle is a ratio of opposite, so the letter O, to hypotenuse. So let's look at this example, and let's say find the sine of angle A. And sine, cosine, and tangent will always go with the angle inside them. So sine of an angle or cosine of an angle, always with the angle. So sine of an angle A, again, it's opposite to hypotenuse. So sine of angle A will be opposite sides, which is A, over hypotenuse of this triangle, which is C. Hypotenuse is always opposite to the right angle. If we take a different angle, let me take, for example, mark angle B, right? Then we're gonna apply this rule. Again, it's opposite to hypotenuse, the same definition. But now we're gonna look at the leg opposite to angle B. So it's B over hypotenuse, okay? So this is the sine, opposite to hypotenuse. Okay, cosine of an angle. So let's say cosine of, let's start with angle A. So AH stands for adjacent leg to hypotenuse. Okay, so angle A, let's mark angle A. What is adjacent leg? So again, A has two adjacent sides. One is leg and the other is hypotenuse. When we talk about opposite or adjacent, we mean the legs, only the legs. Okay. So let's go by definition. Adjacent leg to hypotenuse. So cosine of angle A will be adjacent leg. So the leg that forms this angle, which is B, over hypotenuse. And again, if we have a different angle, we're gonna check what is adjacent to another angle. So we have, it's not the rule that works all the time. So for example, cosine of angle B will be adjacent leg. Now it's A over hypotenuse. Okay, and let's do the last one. That will be the tangent. So tangent, we have O and we have A. Remember, O stands for opposite leg, A stands for adjacent leg. So tan of angle A, for example, it's a ratio of opposite leg to adjacent leg. And tangent is the only function that uses two legs. The other two, sine and cosine, they use hypotenuse in the ratio. So these three are just ratios of two numbers, and it comes with the angle. So let's look for tangent of angle A again. So tangent of angle A will be opposite leg, which is A, to adjacent leg. So again, not the hypotenuse. Hypotenuse is adjacent to this angle, but it's not the leg. So A over B. If we look at a different angle, so for example, if we look at angle B this time, again, we have to check what is opposite now. So opposite is B, adjacent is A. Now, something to remember, since we divided by hypotenuse here and here, sine and cosine can never exceed 1, cannot be greater than 1 or lower than -1. Tangent could be as big as whatever. Now, and I'm just going to include a couple of more definitions here. So we actually have 3 more trigonometric ratios you might see in algebra, let's say. So cosecant is the opposite, that it's the reciprocal of sine. So cosecant of theta is 1 over sine of theta. Theta is angle. We usually use this letter for angles in algebra. And that means, since it's a reciprocal, we're just going to flip what we have here. Let me write it down here. So it's hypotenuse over opposite. So cosine, so secant of theta will be reciprocal of cosine. And that means that secant of theta is hypotenuse over adjacent. And we also have reciprocal for tan. So cotan, let's say theta is 1 over tan of theta. And that means that cotan of theta is adjacent over opposite. Now let's just do solve a couple of more questions. How it works with real numbers. So Let me draw a right triangle. So here we go. So let's say it's a right triangle. Again, we must have right triangle to apply sine, cosine, and tangent. And let's say that is 8, 15, 17, right? Let's call it A, B, and C. So again, what is sine of A? What is cosine of A? What is tan of A? And then we'll do the same for angle B. We don't do it for C, right? We, as you notice, you only do it for oh, hold on. We only do it for acute angles, but actually we can find sine of 90 degrees and cosine of 90 degrees and so on. So B, right? So sine of A, again, I'm going to write here, so, ka, toa. So sine goes as opposite over hypotenuse. So for angle A, the opposite will be 8 over hypotenuse 17. So cosine of A will be adjacent, which is 15, right? So it's adjacent over hypotenuse. And tangent will be opposite over adjacent. So 8 over 15. Now, as you can see, we have a right triangle. So actually, angle B is complementary to angle A, right? They both make up 90 degrees. So look what happens now. Cosine of B, right? Now we're going to look for, sine of B will be opposite over hypotenuse. So 15 over 17. Cosine of angle B, adjacent over hypotenuse, so which is 8 over 17. And tangent of B would be opposite leg over adjacent leg. So what did you notice here? Look, cosine and sine of complementary angles are exactly the same. Because whatever was opposite leg here, for this angle became adjacent leg. See it? So they just switched. And tan of A and tan of B are just a reciprocal of each other. Now let's look at another question. Again, I'm gonna draw a triangle. So we're gonna look at one more question. In the next video, we're gonna learn how to use trigonometric ratios on calculator to find missing sides and missing angles. Okay, so. So let's say we have a right triangle. And let's say we have, this is 24, let's say, and this is 25. And we need to find the sine, cosine, and tangent of angle. Let's make it B. So sine, cosine, and tangent of angle B. And again, you can try A by yourself, and you know that they're gonna just change places. Now, do we have enough? Remember, for sine, we need to have opposite over hypotenuse. So we have hypotenuse. We have the opposite. So for sine, we have everything. For cosine and tangent, we need the adjacent leg, right? So it's missing. It's X. Now, if we have two sides of a right triangle, we can always find the third one, right? So we're going to use Pythagorean theorem, and we know that hypotenuse squared equals to leg squared plus leg squared. So isolate X. I'm going to exchange sides and subtract 24 from both sides. And then take a square root. So double check. You should get, the third side should be 7. So now, once we have this side, we can solve this triangle. So this is 7. So sine of B, again, it's opposite over hypotenuse. So 24 over 25. Cosine of angle B will be adjacent to hypotenuse. So 7 over 25. And the last one, tangent of angle B is opposite leg to adjacent leg. So 24 over 7. And again, as you can see, sine and cosine never exceed 1 or lower than -1. But tangent can be more than 1. Okay, so check my next video to see how to use trigonometric ratios to solve triangles.